In this example, the question is asking how many times does the graph of the given function cross the x-axis. I'm going to graph it later, but before I graph it, I need to explain it a little bit just by looking at the function. Now, I hope you all must have read already that since the function is given to me in a factored form, I can explicitly see the zeros of the polynomial or the x-intercepts, which means the same thing. Okay, so if this is my number line, 0 in the middle, 1, 2, 3, 4, 5, 6, 7, 8, 9. If I extend that, 9, -1, -2, -3, -4, -5, -6. So portion of the number line is shown. By looking at this polynomial, I know to find the x-intercept or the zeros, you'll be plugging in 0 for y and solve for x, right? Now, even without doing much work, I can see that if x minus 3 is a factor, then x equals 3 is going to be one of the zeros. Again, if x plus 5 is a factor, then I can say x minus -5 is going to be another 0. Same thing is true if x minus 9 is a factor, then 9 is going to be one of the zeros. Okay. Now the next question here is, what is happening around the zeros? And if I can understand what is happening around the zeros, then I can answer at which zeros is it going to cross the x-axis. Okay. For this, you must have learned something called multiplicity. Now, what is multiplicity? Like, imagine the factor x minus 3 the whole squared, right? So what this means is x minus 3 is multiplied twice, right? And that's what multiplicity is. So like, how many times the factor is multiplied? X minus 3 the whole squared means it's x minus 3 times x minus 3. So this is multiplied twice. Then if you look at the next factor, x plus 5, this is multiplied only once, so there is just 1. So if you ask what is the multiplicity at the 0 of x equals 3, I would say it is 2. What is the multiplicity at x plus 5, x equals -5? I would say it is 1. And also the third scenario, x minus 9 the whole cubed, this is multiplied 3 times. So here the multiplicity is 3. Okay, so this is going to give us a big difference, because you already would have learned that the graph of a function will cross the x-axis at 0 if the multiplicity is odd. And if it's not odd, then it's going to touch and turn. Okay, so this is something you must have learned from the readings, and I hope you understood that concept. So with that answer, if it is odd, the odd values are at x plus 5, because it's 1, this is an odd factor. At x minus 9, it's 3, that's also odd. So what should happen at x equals -5, at this point the graph has to cross, and at x equals 9 also it has to cross. So the question here is, how many times does the graph cross? The answer would be twice. And what are the places? At x equals -5 and x equals 9. Okay, now let me show you in the graph. Okay, I'm going to plug this in, not filing in, just keeping it the way it is given to me. So I would go x minus 3 the whole squared, and open parentheses, x plus 5. You don't have to waste your time foiling it to bring a big, huge polynomial. X minus 9 the whole cubed. You can do it if you want, then you don't have to. Okay. Now I'm keeping the same viewing window because here at 9 it's crossing -5, so I hope I can see the whole graph. And my goal is to see where it's crossing, right? So I'm saying without even graphing, it's going to cross at -5 and +9. Okay, so this is I don't know if you can read it. -1, -2, -3, -4, -5, and here this is +9. If you want to confirm this, let me go to second table, and we will see at -5 my y coordinate will be 0. So let me go first to find what -5 is. See, at -5 my y coordinate is 0, which is this point. And at +9 my y coordinate will be 0. At 3 also my y coordinate will be 0. But at this point the graph does not cross because the multiplicity is even. Here is also at 0 because this is also considered as an x-intercept, right? Because the multiplicity is 2, the graph is not going to cross this point. Actually, it will touch and turn here. It will just come and touch and turn. So if you come down to +9, my y value must be 0. And again, my y value is 0. Okay, I hope you understood this.